Very good evening to all of you. Are you able to hear me? Venkat, Sripati. Okay, Sripati is saying, sir, audible. Can I get some more confirmations? Okay, thank you. Shibin. Okay, very well, thank you. We'll wait for a few minutes for people to join in, and then we'll get started. Okay, thank you, Balaji. Okay, thank you, Venkat. Good evening, Harshraj. Getting more folks are joining in. Let's wait for a few minutes. Good evening, Aniket. Okay, we have Sanjeev coming in. Sanjeev. Good evening, Sanjeev. Many students are dialing in now. So, very good evening to all of you. Let us see whether our speaker is here. Yeah, I think I could see him. Let's wait for another. Yeah, thanks, Kaushik. Let's wait for a few more minutes. We give around 3 to 4 minutes for folks to connect, and then we can get started.
Yep, absolutely.
Yeah. So what's happening, guys? Today, I think it's raining heavily in Bangalore. I don't know where you are joining from. Raining heavily, and also a couple of IPL matches going on in case you're following cricket. Because there's a match between Punjab and I don't know which team. Punjab and RR, I see today. Yesterday was a thriller match. Anybody following IPL, folks? Yesterday, Mumbai Indians played very well. I mean, it was probably one of the most thrilling matches. They could defend 9 runs in the last over, which was a miracle, I would say, with all Pandyas and Tewatias, the team. Anybody following IPL? Get some responses. Yeah, okay, Sanjeev is telling last over very tight. Retriever is also telling yes, sir. Great. Yeah, Sam's defended very well. Yeah, that's true. Two more minutes and then we'll start. So will we wait? Can you just type in the window if you're I think we always ask this question. Are you a Emertxe student? Are you an intern? Are you a newbie? Right? Are you like you are joining? Can you just type in the window, student or intern or newbie, so that I get to know where they're coming from? Okay. Yes, Sashmitra, intern, then Ashra, student. Okay, Sripati, student. Okay, student. Okay, largest set of them seems to be student. Interns is Govardhan, current Imagery student. Satish, Balaji, Harish, Uday Shankar. Okay, so largest chunk seems to be our student community today. Glad to know that. And you can also type which location you are joining from, which town or city you are joining from. so that you'll also get to know the geographical distribution. So Suraj is from Delhi, and we have Govardhan says Shimoga, so Afsal says Kanyakumari, Sashmita from Pune, Andhra Pradesh says Satish, Chennai says Manigandan, Bangalore says Sanjit, Guwahati says Harshraj, and then we have Vadra, Nainital, Dharmapuri, AP, Kolkata, Kadapa, Ramnath. Great. So we have pretty much good presence all the way from Kanyakumari to Kolkata, right? Good representation. People are from Pune, on the western side as well. East, far east, you can see people from Assam joining today. I think it's time now. Let's get started. So very good evening, guys, to all of you. So welcome all to this masterclass webinar. We host this masterclass webinar every month. So typically we calendarize on a first Saturday of every new month, where we invite people from the industry, people who are experienced in a particular domain, been there, done that, right? They come and share their experience on various topics. We initiated about 3 months back. Today is the fourth webinar in this series. So we called as an emerging technology series, where we are going to talk about the upcoming technologies. So that way we have a very exciting topic today on drones, and also we have a very interesting speaker. It's very special to all of us. In fact, it's a very proud moment for all of us in Imagery to introduce the speaker also. I'll talk about it in a while, right? So let us get started. Let me always run few slides as an introductory thing. So today is the fourth session of the webinar. So people, I think pretty much, known to all of us. I could see almost all of your students. You guys know what we do as a company. We work on employability to make engineers to gain skills and get into jobs, mainly the core industry jobs. And we also work with working professionals, helping them to skill themselves and then get into better jobs. We also have a lot of working professionals in the call today. And pretty much you all know the leadership team in Emertxe. Three of us, Mars, its organization, is a managing director, and myself, Jaykumar, I'm one of the core leadership team member. And I have Mubin, who heads the technology side of it, and he leads a team of mentors. Probably some of you might have met him during your day-to-day classes, especially the offline students. I'm not sure how many online guys have met him so far, but pretty much offline people would have seen him walking on the corridors, or some of you even met him personally, right? So that's about our team. And pretty much, it's been training placement companies, especially in the year 2022. Tons of placements happening, almost like, small, medium, big, every other companies that working across, all the verticals of embedded systems and IoT is hiring our students. We have a lot of such, placements happening. Glad to see this. And this is the webinar motivation, right? Why we started this as far as Emertxe is concerned. So what we felt, when you guys are going through the course with us, or you've done some internship, or you are a outsider who wanted to have a career in this core industry, one key thing that we all lack is mentoring, right? Mentoring from the right set of people. If you see the talks that we have been organizing, they're not theoretical in nature. Pretty much just folks who come and then they share the real-time experiences, right? How they really solve some problems using technology, and what are the challenges that they faced. Also, what are the, if you are aspiring to have a career in what they have done, right? What is that you should be good at, right? If you look at the last talk was about Linux, right? We have Mr. Harikrishnan, who spoke about, how you need to get started with the Linux and how you can build. Probably Hari has been working in in the Linux field for about 18 plus years, right? So what happens when these type of people we interact, and then we learn, and we also typically schedule this on Saturday evening, so that students who are from Imagery, they are off their classes. There's no tension there. I need to do something. And also the presenters also, they're not having the day-to-day work pressure. They can spend a good evening between with us, or with you guys sharing their experiences. So when the very productive session like this happens, we see that the motivation of the students goes up, right? When there's a big picture that is shared, and it opens up our minds. It forces us to think bigger and better, and we all get better at it, right? So that's a two M's I call. Mentoring and motivation are the key factors for initiating this masterclass webinar. Okay. So with that note, let me quickly talk about today's webinar. So today we have a very interesting topic. the topic says drones in aerial imagery, right? So drones are there, as you can see, right? Used pretty much in almost all the domains. We hear about, even it is very simple example being the online e-commerce companies like Amazon, or even food delivery companies like Swiggy are already prototyping drones, right? There is a drone policy that has been framed by the government, and we see drones are being used in surveillance, and then in military applications. So there are tons of use cases for drones, right? So this is one side of it, right? And today's topic is going to be on the aerial imagery. So when I say aerial imagery, we are going to talk about how drones are going to be applied in the industry of the solar, photovoltaics, right? The solar industry, right? If you look at today, the energy industry as such, right? We are going through a huge challenge, especially the summer is in, and you can see the need for electricity has skyrocketed. We're already hearing in the news that there is the coal reserves in India is coming down, right? And also we see the kind of petrol prices that is running around, right? So always we are facing all these challenges in the short term. And if you look at a long-term perspective, we see challenges like the climate challenges, right? Where we are looking forward, right? The world is staring at challenge as we move forward, right? So as we navigate through in the subsequent millenniums, right? One key thing we talk about is sustainability, right? How well we can build a sustainable future for all of us, so that when we leave the world, right? We leave this particular at a better place for our future generation. So that's where the solar comes into picture, where we generate electricity from the natural resources that God has given us, whatever form of God you believe in, right? So the solar, right? So here we are going to combine this particular two things together, right? How drones are going to be used in a solar industry, right? And what are all the challenges that has been faced in the solar industry, especially from the plant maintenance, and how well we can run the plant in much more efficient manner, and how the instead of sending a human to survey all those things, right? How probably sending a drone is going to help us and things like that. So that's a very interesting problem statement to look at, because you are using technology to solve a real, another technology problem, right? It's like more of a two-layer sandwich, you can say, right? A solar industry, on top of it, you're talking about drones, right? So that's going to be a very exciting topic, right? I'm really eager to hear, right? So let me also take a pleasure to introduce Kaustubh, right? Kaustubh Karnataki is a speaker for today. It's a very interesting relationship we have with Kaustubh, right? Kaustubh joined as a campus recruit in Robert Bosch in the year 2014. I clearly remember I even had a word with Mubin. He also very fondly remembers meeting Kaustubh as a fresh engineer out of college, recruited by Robert Bosch, right? And then during that time itself, we found he's a person with a lot of energy, used ask a lot of questions about how to start a company, how to run it, and stuff like that. And at a very young age, he took a plunge. He quit his corporate career, that was a comfortable corporate job with Robert Bosch. He quit and he took a plunge into entrepreneurship. And also passionately followed his vision of building something really, really, not only from a technology standpoint, but from a future sustainability point of view, right? He started a company called AirPro, and very proud to say that AirProbe has been recently acquired by another global player called Dronebase, right? So that's why you can see this company current name is Dronebase. So very recently, it has been acquired by, it's originally started up as a AirProbe, right? So possibly I could call him as our student, or we can say as an entrepreneur or successful entrepreneur, a technologist, whatever name we can give. I know it's really proud to see somebody at a very young age getting successful, and that too in a cutting edge industry like a drone applied in an solar industry, right? So that's a note I wanted to share about Kaustubh. So with that note, I would like to invite Kaustubh to come on video. Kaustubh, can you come on video?
Yes,
All right.
absolutely. Hello,
Power.
everyone.
Yeah. Yeah. So you are visible, Kaustubh. There's a power outage. My internet is on. No worries. So thank you very much, Kaustubh, for accepting our invitation and joining our session. So guys, please, I'll go offline. Means I will go off the video, and then I will leave the stage to Kaustubh. And as always, we have quiz waiting. Once Kaustubh completes his talk, right? We'll make our quiz live in our Instagram. I'll share the quiz code like always we do. and all the participants will get the participation certificate just to keep ourselves motivated. And please feel free to ask as many questions as you can. I'll try to collate a few set of questions and ask Kaustubh. I know this is nothing new for you guys, especially who are attending our masterclass webinars quite regularly. With that note, can I get one go ahead from all of you guys? Can you go ahead and start the webinar? I know I'm sounding very dark because the power went off and I'm still on a phone internet, right? Just as a backup I kept, that is helping me now. Can we go ahead and start? Afsal, are you guys are all excited about today's topic? Yeah, I could also see I'm very excited for Sanjeev. Hashraj says, yes, sir, right? I could see, welcome, sir, excited, says Harish Mahajan. Go ahead, sir, says Gaurav. Okay, so thank you very much, guys. Let me go off the video first so that I don't look like a booth for you guys. And let me share this. Let me change the permission to Kaustubh. 1 minute. Kaustubh, are you able to get the
Yeah.
permission?
Yes. Can you see my screen, everyone?
Yeah, we can see. So over to you, Kaustubh.
Perfect. Nice. Great. Firstly, thanks, Ajay Kumar. I mean, for a kind introduction. And it's also great to know about Emertxe, and definitely I've been following up Emertxe as well. So, hello everyone. I'm Kaustubh, and I really appreciate the Emerging step in actually arranging such webinars, right? Especially about mentoring and motivation. I could recall my days during engineering, right? Just almost 10 years back. I remember my days like how important it was that how to actually bridge the gap between what's happening in the theory in academics and how to bridge the gap within the industry, right? And that's where mentoring and motivation comes an important play role. And I remember many of industry experts did come to our engineering college and did give us the flavor of what's happening in the industry. And happy now that I'm on the other side here. Really good step, Emerging here. Thanks for that. And yes, there's a definitely a good personal story as discussed by Jay Kumar, wherein I mean, Jay Kumar sir and Mubin sir were my mentors there in Bosch. And then the journey goes on. A lot of things in the play. So I thought, now while I was a student, I got so many opportunities to meet industry experts. And also, while in Bosch in the training, got the same from Jay Kumar and Mupin. How about keeping the ball rolling, right? So many students applied and even attending this session. It's important that how the technology or even the studies which you do in your academics, how that can be applied, or whether it can be applied, if yes, how it could be, right? So thought to share my journey through this and giving you a flavor of solar industry and also how drones are used in solar industry mainly, right? Quite interesting topic to say. It's drones. You might have seen it in many places now, quite common, especially in weddings, very commonly used, right? So with this session, what I wanted to share with you is when it comes to large solar panels, right? I will explain to you what is all about it, right? They are spread across hundreds and thousands of acres of land, right? Currently, we have manual conventional methods to actually identify if there are any problems in the asset. But what are those problems and how much big the problem is, right? This is what we'll go through. So in this session, you will be getting slightly exposed to a bit of solar PV, a bit of basics. So maybe you will see kind of like some part of electrical engineering, some basics there. So don't worry, I'm not going to bore you with a lecture here, but yes, we'll give you a flavor of some basics of solar and then jump on to what are the solutions or basically how drones would actually bring a transformation in maintaining this large assets. So this is the goal. And one key thing is at the end, I would also have a simulation demo of how actually we can program drones and fly drones. So I will have a simulation board here. I would be happy to show you that at the end. So stay in tune, right? So let's start with the session. I majorly manage the operations and analytics here at Dronebase Asia Pacific. right? Basically, 2017 is where I co-founded Airprobe along with Aditya. Airprobe was a company wherein we had developed a digital platform in order to improve the reliability and efficiency of solar PV assets. Just 3 months back, as Jaykumar mentioned, our startup Airprobe got acquired by Dronebase USA, right? I'll be definitely sharing you the details of the journey again. So Dronebase is a US company, right? A quick one slider on it. Is a US company which is developing an intelligent imagery platform, wherein that one platform could be used by different infrastructures like wind, solar, even buildings and properties, and also the construction industry itself, right? Basically, using drones, we want to transform how this processes and entire development of these assets and maintenance of these assets can be taken care. We believe that these infrastructure assets are so long term, are almost like 20 to 30 years. It's almost impossible to manage this all through manual methods, right? And when these infrastructures are spread across big heights and big land areas, again, we need robotics or drones which can actually help us manage these assets. So currently with this session, we'll be focusing on the solar solution with drones and how do we maintain solar assets using drones. While I realized that this session is designed for engineers, majority of engineers, right? I thought, how about actually sharing my journey a quick. So this picture you see is right from the table of my final engineering project in 2013, right? While I was with my team working on how we can improve the efficiency of solar PV panel. There you see MSP 430 and many other controllers. This is almost 8 years back, guys. I mean, you can see all the college stuffs, lab stuffs there, right? The journey started from here, right? While I was in final year engineering, right? There was first question, what topic should we work on? And interestingly, while we were searching for a topic in engineering final year, our professor, he suggested to meet an industry owner because he was facing a problem. We went to that industrialist, we had a chat. He mentioned, can you design a solar panel, solar system for me to charge my electric vehicle? That was the problem statement given. Quite interesting problem statement. And he not only wanted to do it as a project, he wanted to make it as a commercial solution, right? I mean, basically implement it for him. That was a quite challenging thing. We didn't know even S of solar panel those days. That's where we realized, okay, solar forms to be an interesting field. Let's explore. And this is where we realized that how we could basically go into different topics in solar and realized what are the things which we need to explore and bring up to the industry, right? So performance of solar panel can be fine-tuned in two ways. One is the mechanical way, wherein we can actually track the sun, right, using the solar panel, right? I mean, sorry, track the solar panel so that it faces the sun all the time mechanically. There's a second way using embedded systems, wherein you can program the output of the solar panel such that it maintains at the maximum operation of the performance. The journey starts from here. So if you realize now that you guys are in engineering, I would highly encourage you to not just go by a topic which is generally found on Google or so. Talk to industry people, talk to peers, talk to your friends who are working in industry, understand what is that problem which excites you, right? And that's where if you corely and dedicatedly work on it, you never know that solution could be actually a big problem solver in the industry, right? And in fact, I'm happy to see how this work in solar, which I've done with my team in final year engineering, made me drive my career path entire into solar sector till now, and it's been already 10 years working in solar sector, right? So remember, guys, final year project, don't undermine the power of it. So just wanted to share you this story. So the story now you see on this table, which you see one small solar panel there, which is a 10-watt solar panel. The journey starts from here, and within 5 years after this final year project, the journey is currently here. You see me there standing below, along with my co-founder Aditya. This is the first project which we did while in AirPro. You can see this is the world's biggest solar park, that is the Bhadla Solar Park in Rajasthan, India, right? You can see us there, and obviously it's a drone shot. Basically, this is a huge solar plant and a combination of solar plants, as you can see in the horizon, right? Our job was to actually identify problems in this large sea of solar panels, a very huge problem, right? And the question comes how we could identify this. I mean, if you want to do this particular activity manually, it's going to take months and years to perform. Right? You can see this, how big it is, right? Now, considering this as a problem statement, let's go slightly deep. Let's understand a bit about solar. Let's understand the basics of solar panel. Let's understand what are the problems. And let's see how drones could actually solve this problem one by one. Right? While in between, if you have questions, feel free to put it in chat. Maybe Jay Kumar and the team could read it to us, and we can have that discussion as well. So no worries. So let's start with the first photograph here. What you see is, again, another picture of a big solar asset, right? And to give you an understanding of how big is this, the blue color rectangles you see are the solar panels. The size of a solar panel is almost like a standard door size, a door, like entrance door. And to compare that, you can see we standing, our group standing over there. Now you can imagine how big solar assets are, right? The biggest, one of the biggest being in India itself, right? So this is a picture from the same solar park. Now the challenge is we have so many of solar panels electrically connected to each other. As you already know, solar panels are responsible to generate electricity in DC form directly from sun, and that DC electricity is passed on through inverters, which is converted to AC, and then it is supplied to grid. That is the job. But now, and we also know it's a renewables, right? It's a sustainable electricity. So the life of a solar plant is almost 25 years, right? Imagine this, thousands of acres of land filled with sea of solar modules generating gigawatts of power for India, right? And connected to national grid. When you have such a huge asset of solar panels, even a slightest problem in one of the solar panel, the problem could be the glass which is actually used in frames. What if the glass breaks? It can break due to many reasons. What if there is a dust on the solar panels? Can it generate as efficient? What if there are rodents or rats in this field which can actually cut down the electrical wires and actually make this plant also shut down? What if the solar cells which are designed here, they have cracks? That becomes a risk for the investment which is being done on the solar panels, right? Now, but even if you have this lakhs and a million of modules spread across, how can one understand which module has what kind of problem? Just to help you understand, for this solar field which you see here, if a person has to manually go across the site, that person and see each and every module, even 10 people will take almost 1 year to cover this entire plant. 1 year, 10 people to cover this entire plant, just to see if there are any problems in the modules. And this is required in a periodic way. We cannot just say, let's do it for 1 year and we are ready for the entire plant to be generating as per expectation, right? It's year on year requirement. So how to actually solve the problem? One of the ways is, why not use sensors? Why not use power sensors and actually put it on each and every solar PV module and get the data, use IoT techniques, get it on cloud, see the generation of each and every module. Why not that solution is used in industry? Yes, it is used, but it is used for smaller assets which are on rooftops. You might have seen some solars on the rooftop. There are IoT-based sensors used in those solar plant modules, and basically they throw in the data onto cloud, and you can measure the generation of each and every module. But imagine when it comes to millions of scale of solar modules, the hardware costs and the software costs involved in actually deriving the solution for monitoring each and every module's generation is not economical. It's very high for the industry, and that's why the hardware devices for each and every module does not make sense, right? So that's a That's a problem. Now, how to solve this problem? One interesting attempt is, rather than having sensors in each and every module, why not have a sensor over say a robot like a drone, and the sensor moves around? Can this be possible? What kind of sensor it is? And even if this is possible, what is the value it can bring, and how we can actually, how the data looks like? What can we figure out through that? What if 1 year for 10 people, one site, how much can the drones do this, the same activity, in how much time? There are so many questions which come in, right? And this is all about drones in aerial imagery for solar photovoltaics. This is a picture of mine of how conventionally people actually, electrician technicians manually should go to each and every module to understand and measure its performance. Now you can realize this photograph and this photograph. Now this is just literally taken on ground while we actually testing one particular module. Now you can realize the scale, what we are talking about, right? So this is a huge industry problem to be solved. Let's go one by one now. How is it all possible? Before that, it's important to actually understand solar PV cells, slight basics of it. We'll go into slight bit of theory and then again go back to our practical understanding of the industry. Right? So coming to solar PV cells, right, as we discussed, it generates a DC power when sun's radiation fall over it. One important question, when we say that solar cells generate power, is it like the moment sunlight falls over it, it generates the rated power always? Or does it have a variation? How does it vary with sunlight? How does it vary in the morning, afternoon, evening? So many questions, right? And also, how does it vary with respect to the angle of the solar cell with respect to sun? Will it change? Will the generation change? How does it change? So many questions again. Not only that, can I just use solar cell, connect a bulb, a DC bulb, and directly get the power? Can I use it directly, or do I need some hardware in between? There's so many questions again, right? Obviously, there are a lot of materials online which I encourage to use, but I've taken some snippet of it. I would like to show you here for a while. Going to basics, the left side curve which you see is called voltage and current IV curve of a solar panel, right? Do not get panicked by this graphs and nothing much about this. It's not going to be, there's not going to be exam for this, but would like to give you an hint of how solar panels generate electricity and how that can be measured, right? Basically, when you take a solar cell and when you connect a load to it, right? Depending on the resistance of that load, the panel starts generating power, right? And basically, this is the blue color curve you see is called the IV curve, right? The red color curve you see is the PV curve. That's a power curve, right? IV is the voltage and current. Now the question comes, where does the solar panel operate? I mean, when we say that solar panel generating power, what is the operating point? If you see this curve and in terms of mathematics, which point can generate the maximum power is this particular point, and this is called maximum power point, right? So if the solar panels can perform at this particular point, it is generating maximum power. If they are generating at this point, they are not producing maximum power. So it is important that by a combination of hardware, how we could actually make the solar panel perform at maximum power. So this is one of the ways embedded systems are used in solar panels to ensure that they generate the maximum. That was the final year project I was talking about. And then how does it vary with radiation, right? If you see that radiation one, so irradiation is the sunlight falling onto the solar panels. Higher the radiation, higher the performance. Lower the radiation, lower the performance. Now you get to know that the power generated by solar in say noon time or afternoon time is always higher than compared to sunrise or sunset. It's just mainly due to the sunlight, quantum of sunlight falling onto the panels. And then comes, depending on temperature also, a solar panel installed in Bangalore. And when you compare it with a hotter state like Rajasthan, the same panel with the same radiation will definitely perform differently because of the temperature differences. So as the temperature of environment increases, the solar panel's performance also reduces, right? So it's not only the radiation, it's also the temperature. Higher the temperature, lesser the performance. This is the fun part of game, because when you compare it with the solar heaters, right, the water heaters, higher the temperature, more better the performance of the solar heater. But remember, we are talking about solar photovoltaics, solar PV. This is the principle wherein we are generating electricity from sunlight. And here, temperature is an enemy. Higher the temperature, lesser the performance. Some quick basics. Now it's important to know how is a solar, like when we say solar module, like the rectangles which you saw here, what is that square indicating? Yes, those are solar cells. How are those connected inside a module? And how are they generating? What happens if there is some problem? Let's go slightly into details. This is a quick schematic of how solar module looks like, right? Each of the small rectangle is indicating a solar cell made of silicon. They're all connected in series. Okay. Yeah, I mean, it's an electrical term, series parallel. I mean, if you are not exactly clear, no worries. I'm not going to go into detail, right? But basically, they're connected in series or a sequence with each other, positive and negative terminal together, right? Now, interestingly, you also see that among the 72 solar cells which are connected in series, there are also bypass diodes connected in parallel to, say, 24 cells here, 24 cells here, 24 cells here. Now, again, people in electronics or electrical will understand this, but others, no worries. I'll be able to help you. What is the function? Basically, diode is acting like a gate. It will allow entry of current in one direction and will block the entry of the current in other direction. That's all. Right. Now, it's important to understand when we have the solar PV module and solar cells, what is the functionality of these diodes and basically what's happening in the solar cell. Whenever the light falls onto these cells, basically the silicon cells generate electricity by transferring electrons from valence band to conduction band, and the electron flows. Electron flow is current generation, right? That's how the electricity is generated. Now, what if, because they are in series and electrons flow in this series, we know that in series the current remains the same, right? So what if this solar cell breaks? Imagine that this sequence, the solar cell breaks. Then the flow of the current is blocked, am I right? Or if the solar cell has some problem here, right? Then there's a resistance of the solar cell. Again, the current is blocked. Then if you see there's so many solar modules, what if one solar cell is damaged? Will it make the current zero through all the 72 cells? If that happens, then basically there is no use basically of solar cells, because a slightest of damage can make the solar performance from 100% to 0%, right? That becomes a problem. What if there is a shadow? You have seen rooftop solar. What if there is a shadow of water tank, trees on this panel? And that too, not entire module shadow, partial shadow. The solar cells get partially good radiation, partially high radiation, right? I mean, low radiation. Considering this mismatch, again, there can be a blockage in current. Now, to avoid this blockage in current to impact the entire module, we have diodes. Basically, whenever there is a blockage, say example, this particular cell is broken and this is blocking the current, this diode activates and allows the current directly to bypass through this out of this 24 cells, and the current still continues to flow, but these 24 cells become inactive. That's the function of bypass diode, right? Don't want to go into details, just wanted to give you a clear picture there. Happy to take questions on the chat if you have any, right? But remember, if there is a problem in one solar cell, it's going to create problem for entire module. However, bypass diodes are there to protect that, wherein one cell can impact the 24 cells and not the entire 72 cells. Right? Now that we have learned of understanding how, yeah, there's a question.
Also, there are questions. Can we take them before we move on?
Yes, please. Yes, please.
Okay. So there are, I think, 4 to 5 questions have come up. So let me take, okay, yeah, I could see four of them. So there's a question from, a lot of questions from same person, Sanjeev Basak. His first question is, I think you already touched upon it to a little bit. He asked, like, any standard angle is there to install the solar panel for better output?
Very good question. Yeah. So a good question there. Basically, a standard for solar panel angle. So there are two ways. Whenever you see solar panels which are static, static is there is no mechanical movement. Depending on the latitude and longitude where the solar panels are installed, we decide the panel angle, right? Basically, in India, all the solar panels are facing south when they are static. Static in the sense mechanically non-tracking static. So all panels are facing south. The angle of panels is calculated. There are various softwares available because it depends on which geography, right? To give an example, if you take Karnataka, right, majority of solar panels in Karnataka will be inclined at somewhere around 25 to 30 degrees. So if there's a tracking system, every day it completely tracks the solar panel and it tries to maintain perpendicular angle with the sun's radiation. So that's where the tracking and non-tracking comes for solar panels. I hope that answered the question. Yeah, Jay Kumar, any more questions?
Let me just check.
Sure.
Sanjeev, is it fine? Did that question? As he types, let me move on to the next question. There's a question from Ravi Kumar Gupta. He's asking why we use diode if solar panel generated DC.
Why do we use diodes if solar panel generates DC? Interesting question. Basically, what happens is solar panels generates DC. That is correct. The functionality of diode is nowhere related to generation of solar panels, but it is to protect the solar cells as discussed, right? If you see this, diodes are in a reverse bias condition. I mean, the negative connected to positive solar cell, positive connected to the solar cell, right? In a reverse bias condition. So basically, whenever solar cells are generating, it is in an off condition. Whenever there is a blockage in the current due to this particular solar cell, say, for example, and this branch is not generating, that time is where, rather than impacting the entire 72 cells, the diode is in an on state. So now the circuit basically closes through this and goes directly to the second branch and the third branch. That's how it is. The functionality of diode is to protect solar cells. It's nowhere involved in the generation of it. Yeah.
Is it clear? Ravi Kumar Gupta. I think Sanjeev is acknowledging. He's answered this question. Okay. Ravi is also telling yes. And there's a question from Gaurav Kulal. Gaurav is asking, is PV cells damaged if they get sunlight beyond their limit?
Nice. Basically, solar cells generate, as you see the graph here, generate like there is a graph here, as you see, generate based on the radiation. Now, there is a upper limit of radiation in a practical scenario. Okay, so answering directly a question, will solar panels get damaged with higher radiation? Answer is no, they will not get damaged. That's the answer. But remember, as so solar panels are rated at 1000 watt per meter square. Watt per meter square is the unit for irradiation. If the radiation goes above 1000, the solar panel, which is 300 watt rating, and if the other test conditions are maintained, it can also generate more than 300 watt peak, right? It can generate more power, yes. It's not going to impact the panels actually. So in fact, during manufacturing process, they take care that the panel is also able to handle 1.3 to 1.4 times larger radiation than practical radiation. That's why practically whatever sunlight falls onto solar panel for entire 25 years of time, more the radiation, more the power, but it's not going to damage the solar cells.
Is that answers your question, Gaurav Kulal? Okay, yeah, clear, sir. Thank you. There are a couple of more questions, Kaustubh, before we move on. And there's a question from Shweta Shri. Shweta is asking, isn't that a disadvantage that the 24 panels are getting the impact from one fault panel?
Correct. Very right point. In fact, this is also a question being discussed in industry, that why there are one solar cell can actually cause problem in 24 cells. And I mean, it was supposed to impact 72, but thanks to bypass diode, that it is 24 cells. And is it bad? Is it really bad? Yes, it is actually bad. But the problem is there is no direct solution to it. Rather than impacting all the 72 cells, it's okay to impact 24 cells. However, there is one way how we can actually eliminate, like literally one cell gets damaged, only that cell gets impacted, all other cells are active. How is it possible? Connect diodes to each and every cell. Each and every cell, like 72 cells, 72 diodes. Connect it, and one damaged cell will basically not create any problems to any other cell. That's possible practically. But economics of using diodes for each and every cell again does not allow us to do that. So the power loss which we will face by losing the 24 cell generation is still okay than using diodes for each and every cell and putting that cost economics out. That's why practically it is possible that we can put diodes across solar cells in each and every solar cell and make sure that it's not impacting the other cells. But yeah, the economics doesn't allow. So the balance is using 3 diodes and let the 24 cell get impacted.
Okay, great. Shweta, hope that's clear. One more question, last one, and we'll keep coming, right? I could see more questions from Amarjeet, Harshnath, and all. I'll take one question and then we'll come back again. There's a question of Vinay DR. Vinay is asking how the cells can generate electron flow, on what principle do they function?
Got it. So basically, electron flow, right? It's principle of photovoltaics. That's the principle. And now basically, it's a silicon material, right? And silicon again has valence band and conduction band, right? So sunlight has photons, right? I'm going into basics slightly. Photons fall onto the solar silicon cells. Whenever the photons fall onto those cells, the the electrons which are in the valence band are absorbing those photons, basically absorbing that energy. They get excited to conduction band. The moment they get excited to conduction band, so example now, this is the solar cell, and if it gets excited to conduction band, that electron, because there is a closed electrical path, it actually flows through the path, and that's why it's able to generate an electrical flow, right? Remember, if this particular cell was damaged, then there is no electrical path for the cell, basically closed path. So the electron which was in conduction band, which cannot move to external circuit because the external circuit is open, then the absorbed energy is released as a heat, jumps back to valence band by release of heat. And that's why solar cells which are not generating or are damaged, they have higher temperature than normal operating cells. An interesting principle here, I repeat, that solar cells which are not generating or inactive have higher temperature than normal operating cells because the electron which was excited by absorption of photon does not have external circuit path. It jumps back to conduction valence band with the release of heat, and that heat is the temperature rise. Yeah, and that's the principle behind thermography, which I will be explaining to you next. Yeah.
Thank you, guys. There are still a few more questions. Please keep them coming. I think we'll request Kaustubh to continue. We'll probably, take few more slides and then we'll come back again. Okay. Just before
So
I hand it over to Kaustubh, guys, are you able to see the connect so far? What has been shared with you? I know it's like a very initial part of the presentation. Can I get some quick response? Are you able to connect what the scale, the challenge that we are up to, and then how the technology is using to solve the problem? Okay, great. Vinay, Hari. Okay, great. I can see so many responses. Thanks a lot. Please continue, Kaustubh. We'll come back again, take questions.
absolutely. Nice to see the enthusiasm, guys. Keep it up. And yes, how the technology can bring impact is the main part of the session which is oncoming. So let's go brush up through basics. Now we know this solar PV module has 72 cells. Like, how can a 72 cell, what is the wattage of it, right? Remember, manufacturers produce solar panels as small as 2 watts, 5 watts, to as big today in the market of 400 watts, right? Watts. I mean, again, circuit branches will understand these terms, but yes, 400 watts, and that's where the size of a entrance door is. It's a 72 cell size, almost a entrance door. This is the wattage what we have. Now, when we talk about solar plants, we talk not only in watts or kilowatts, maybe kilowatts we talk in rooftop solar. But when the picture you saw of the entire utility scale plant, it's a utility in the sense, basically the large scale solar plants, we talk in megawatts and gigawatts. 1,000 watts is 1 megawatt, 1,000 megawatts is 1 gigawatt scale. But now it's important to know, when you saw the sea of solar PV modules, how are they connected to each other? Are they connected in series? Are they connected in parallel? What happens if we connect everything in series, everything in parallel? So many questions, right? Let's go it one by one then. So in practical solar PV plants, modules are connected in both series combination and parallel combination. Okay. Again, we'll go slightly into details, series and parallel combination. Now, what you saw here, 72 cell, you can see this as one particular cell over here, right? Now, what did we say? We have panels in series and parallel combination. When you have this group, like one series line of solar PV module, that is this, right? This is called one string. One series of modules is called a string. Multiple strings are connected in parallel. Okay, multiple strings are connected in parallel together, right? Why are we doing this series parallel combination? There are certain reasons behind it. As we said, one panel is say 400 watt peak. Now we want to build a 1000 watt peak system through it, right? What is the combination we can put for, or we want to build 1200 watt peak system, that is 1.2 kilowatt system. We can put a 400 watt peak panels, 3 panels in series, or 3 panels in parallel, right? But electrical people or electronics people will understand when we have modules in series, the voltage increases, the current remains the same. Or when we have parallel connection, the voltage remains the same, the current adds individually, right? That's how it is. And that's why it's a combination of series and parallel. Basically, they're all mechanically connected to one string combiner box, right? Basically, what is string combiner box is a mechanical couple between multiple strings coming in, and then that particular string combiner box will be connected to inverter. How it is connected is this. As discussed, now there are multiple string combiner boxes which actually are connected in parallel together, and then they are supplying the DC power to the inverter. Okay, this is how the electrical connection goes. Why inverter? As everyone knows that national grid is having AC power running through it. And definitely we need to feed in that AC power synchronized with the particular voltage as well. That's why the inverter functions as a component which converts the DC power to AC power, right? Now this is how a connection is done from solar PV module to strings to string combiner box to inverter, and now inverter to the basically the national grid. Obviously, the national grid is designed in different voltage configurations. It can be 33 kV voltage, 110, 220, and then there are transformers which actually manage the voltage variations from inverter to the grid, and that's how the coupling goes. Again, need not go into details, just understand at the overall view how a solar PV system is designed and how it looks like on a schematic. Okay? This is what you see in theory, right? And what you saw in practical is a photograph, right? So yes, so basically wanted to give you a quick understanding of how the entire solar PV system is designed. Right. Let's go next now. We will be discussing now the practical aspects. Till almost 10 minutes, we have been discussing about the theory aspects of solar PV. Now let's go into the practical aspects. When we want to design such huge solar PV plants, right? What are the phases? What are the challenges in each phase? Let's go one by one. As said, solar PV plants are designed to be spread across thousands of acres of land. So first step comes, that is a planning stage, wherein the entire land is surveyed to understand how the land terrain is. Is it undulated? Is it flat? And then entire solar PV plant is designed by civil engineers using AutoCAD and many other tools to do a design. Right? Once the design is done, the entire plant design is simulated onto different tools. One of the famous tools is PV-Assist. The design is simulated to understand how much power can this solar system generate. So we saw there was a planning stage wherein a piece of land is selected, a barren land. We understand the terrain information or contour of that land. The design of that solar plant is done. Simulations of solar plant is done. And if the investment being done on solar plants is enough to generate that and give a good return on investment, that's where a solar plant deployment or construction is approved. Right? I'm going on a very overview scale, not in details, but yes, I hope you got the story now. Now, the first part after the solar plant is approved starts the construction. Let's go into that. We will now discuss mainly about construction of solar PV modules. I've taken this image from internet, wherein you see how the panel of the size of solar panel is and how they've been handled safely by the engineers and they are being mounted. We are talking about millions of modules, like about 10 lakhs, 20 lakhs. So what is a typical timeline of construction? A typical timeline of construction for a site which is almost spread across 1,500 acres of land, it's almost a year. So within 1 year, a 1,500 acre capacity plant, which has almost 11 lakh modules, needs to be constructed, right? And the construction starts literally with drilling holes, deploying the structures, and then deploying the modules, then electrically connecting the modules, electrical components like inverters, transformers, electrically integrating everything, and then connecting to grid. Did you see the flow? Quite a huge, right? Now, when you have such a huge construction happening, how can we monitor the construction? Quite interesting problem, right? 1 year of construction and investments, like just to give you another picture of what's the economics involved in solar systems, a 1 megawatt plant will cost you somewhere around 5 crores. 5 crores, 1 megawatt. And when I say 1,500 acres of land, the scale I'm talking about is 500 megawatts. So 500 megawatts into 6 crore, that's the investment being done on this. Now you can imagine the mathematics and what's the cost in deploying a solar plant and running it as well. Now, having this much investments been done and so many expensive components present at site spread across this huge area, how is it possible to monitor the construction progress becomes a question mark. Currently, what happens is engineers move around each and every parcel like that defined engineers team, just move around the site, walk around, see, note down on Excel sheet or by note pen and paper, what's happening, how many modules are installed, how many drill holes are drilled every day in this bright sunlight with the temperature of 40 degrees, right? Imagine the problem. And still they cannot outreach the entire area. They have to do it on sample basis, right? They cannot measure the entire 1,500 acres, monitor on a monthly scale or on a weekly scale what's happening. It's not possible. Now this is a problem. So to see what are the problems involved in construction, if you see, right? The project progress is tracked manually, and it's all about in pen and paper and Excel sheets, right? There are a chain of people involved. Like there are tens of engineers running around to see what's happening. They come in the evening, fill in the Excel sheet manually, mail it to the supervisor, supervisors validate. Every day, the chain of process just keeps on going and everything is a manual entry. Remember, manual entry brings errors, right? Not only that, when I speak about investments, remember that because this is in open land, there's a very common stories of theft and pilferage during the construction of sites. A lot of solar modules are stolen, a lot of electrical cables are stolen at the site. And when you have such a huge area, how is it possible to monitor these activities? Impossible is the answer. Manually, impossible. Plus, the last point, as you see, the manual process is time intensive, it's expensive as well, and obviously it's erroneous because it's manually managed. Every day for 1 year to actually 10-member team going around the site and noting down is not an easy job. How to solve this problem? Can drones be used here? That becomes one of the interesting questions. Now, when we realize that yes, drones could be used, how it could be used and what value can it bring on the table, right? What we did is we went to a solar construction site. We realized their problems. We had a drone with us, right? We programmed that drone through GPS actually to fly over the entire area, right? Now we calculated how much time a manual person, if that person or even 10 people have to run around the entire site, how much time those people will take to count the progress of construction. One cycle for 10 people to run around the construction site and note down the points, what's happening, is going to be 3 months. Remember, for construction, noting down 3 months. Within the 3 months, 20% of construction is already done, but they have just completed one cycle. We compared that if a drone flies in an automatic path to cover that area. Remember, I'm talking about 1,500 acres and a 500 megawatt peak plant, right? How much time will it take? Interestingly, we saw that a drone could cover the same area of 1,500 acres within 4 days. So imagine 3 months manual work of 10 people, one drone engineer at site, 4 days, entire plant is getting scanned for construction. Now, this is just about the data acquisition, the imagery capture, right? This is the power you can see. 3 months brought down to 4 days. What's next? Now you got images. what you can do, you can form a big map, panorama, right? Similarly, we capture images, we form a big map of the entire plant under construction. But again, it's very difficult to actually understand in that map how many drilled holes are there, how many modules are being installed manually. Again, it's a challenge, right? Obviously, it's much better than running around on the plant, rather to see the data online. But the issue is counting on holes, which are again lakhs and tens of lakhs in numbers, is not an easy job when you want to do this on a weekly basis. 4 days, the data is collected. The reports needs to be generated within 3 days, because there's no point in giving reports after 2 weeks of manually counting on the drone data I'm talking about. And that's where comes the power of AI or artificial intelligence, wherein we train models of imagery to identify those objects. The objects could be the drilled holes, the structures, the modules, and actually count automatically on its own. Depending on the accuracy, we get the output, and then there's a slight quality control needed to ensure that the accuracy is maximum, and through which we are able to give the statistics as well. And this is what the process looks like, right? The data acquisition at the site happens through drones during asset construction. The data is uploaded onto cloud servers. There is a deep learning engine being trained to identify these objects, and those objects are identified, statistical counts are performed, and the entire insights can be actually presented over the portal, right? This is what Dronebase has been providing solar construction assets globally to actually help them understand the progress of that construction when you have crores of investments done on these assets, right? Now you realize the process. The 3 months got down to 4 days, right? And the power of AI actually makes it possible within 2 to 3 days to give the outputs to help them understand what's been the construction stage at that week. And this can be repeated on a weekly basis. Now you saw the power, right? Drones in solar asset constructions. Yeah. Now, once the construction is completed, right? Say example, 1 year is done, 500 megawatt is constructed. Now it goes into the operations phase. Right? And here is where the main challenges start. Here's another picture of a huge solar park. Again, a sea of modules you see across, right? These are all completed construction, right? And they are electrically connected to grid and they're producing power. Remember at the start of the session, we discussed that a problem which could be a glass crack, cell damage, even in a single module can impact those 24 cells. But not only that, here I'm talking about millions of solar modules. In this millions of solar modules, it's very common to see thousands of solar PV modules not performing. In the previous part of the session, we spoke about the solar cells, right? We spoke about strings. We have also seen practically that strings are electrically connected to inverters. What if there are rats which actually bite those strings and the electrical wires are cut down? The entire string, which has almost, say, 30 modules or hundreds of modules, are disconnected to the system. Now, if you see that we say solar energy, is green energy, yes, but remember it requires maintenance. It's not that install solar plants, sleep for 25 years, you get free energy. That's not the case. It's very important to maintain those solar plants. And to maintain those solar plants, when you have sea of modules, we discussed, if you have 10 engineers running around, they're going to take almost a year to actually figure out each and every module's problem and study those problems. Till then, while they come out and say there are thousands of problems, there will be another thousands which already popped out, new ones in that 1 year. So many problems, right? Now, that's where we discussed why not actually make a sensor fly to actually understand the performance of each and every module in the solar asset. Now, first question comes, Kaustav, what is the sensor we are talking about, right? And how can we, from a drone, actually understand the performance of solar panel? If you see a photograph of solar panel, no one will understand, okay, we can't even understand whether it's generating or not generating. So which sensor can help us to actually identify the generation of solar modules? There's an interesting basic theoretical concept behind this. Remember, we discussed from one of the questions from your friend who asked that if a solar cell is damaged, basically what happens if it is blocked, or what if the entire 24 cells are blocked? Right? What happens? We also mentioned that if there is a solar cell break, it blocks, the resistance increases. And remember, we also discussed if it blocks, the resistance increases from the principle of P is equal to I square R, the temperature increases of the solar cells. The temperature of damaged solar cells increases. Temperature of normal solar operating cells is at normal operating temperature. Now, did you understand? The game of temperature has a lot of information hidden. And this is where we can actually make use of a technique called thermography, right? Thermography is basically a process wherein we use thermal cameras or thermal sensors, right? The thermal sensors are able to get the temperature across the entire field of view, right? The temperature of solar PV modules. Now, by looking at the temperature patterns of solar PV modules, we're able to identify certain signatures of hotspots, which we will actually see a video also of a thermography happening over a solar site, right? We will see some temperature differences, and by the pattern of those temperature differences, we can identify what is the problem in solar panel. It's similar how a doctor diagnoses your patient's health and gives a prescription. Through thermography process, we are actually flying drones, helping looking at the thermal signatures and trying to help the owners identify the problems in their solar plants by giving prescriptions. It's not only that, hey, out of a million of modules, you have 10,000s of modules having problems, go and fix it. No, we also provide them help. We also help them understand that, hey, in those 10,000 solar PV modules from that thermal signature, these are the problems. These are the category of problems. The severity of these problems are A, B, C, right? So you need to basically fix this ABC problem first and actually move ahead. By fixing those ABC problems, you will be able to perform more. If you perform more, basically you will be exporting more to the grid, right? That's exactly where more green energy is generated, which means that it's not only about installing green energy, maintaining green energy is important, right? That's where the drones play the role. What am I talking about in terms of temperature, thermography, thermal signatures? Let's see those one by one, right? Before that, let's talk about problems, right? Basically, we discussed the investments are heavy on the solar panels. About 60% of the investments goes on the solar panels. We also discussed that if IoT-based sensors are used on each and every solar panels, the economics is high, cannot be used. Further, right, when the testing or the performance assessments happens over solar plants, manually performing the performance evaluation is not possible, right? And now if each and every person goes on each and every panel, we know the time taken for us to even inspect or understand the solar panel plant in one cycle is going to be 1 year. Not practical. How to solve this is basically drones again in solar operations. This is one of the custom drone made in India, right? And you can see that there are two sensors over there. One is a thermal sensor and another one is a visual sensor. It's a combination of two sensors being used on the same drone to capture both the data. One is the thermal image and another one is a visual image. We'll discuss what is the use of both together as well, right? You can see the scale, right? You can see the size of the drone and you can see the size of the car there, Bolero standing. How funny it is to see the sea of solar modules. Right? Now let's see what these drones are bringing on the picture, how it works. Similar to construction, we are able to basically fly drones and capture the data, right? Now the data is thermal images. How do the thermal images look like? And how can we identify? I will give you a sample video example also just after this slide. But coming back, right? So first question, Kaustubh, you mentioned that the 10 people are going to take 1 year to actually inspect the entire solar plant. What are the drones bringing on the table, right? Basically, drones have a power to actually inspect the entire 500 megawatt plant within 10 days. 1 year got down to 10 days. 10 people gone down to one drone pilot. And that's where the power of drones comes in, right? These drones collect these thermal images. This data is uploaded onto servers. Again, Dronebase has developed an AI engine to go through all the drone images and identify the problems through the thermal signatures. not only identify, it's also important to locate the problems. We are talking about tens and thousands of solar modules having problems, and it's spread across these large hundreds of acres. Then the AI engine basically is learned to see the thermal patterns, identify, categorize those problems, and also locate those problems using computer vision algorithms. That's how the technique is used. Finally, all the data is available onto a cloud portal, right? This is how a cloud portal looks like. Finally, it will get like a kind of Google map with the entire map with a visual map around, and the balloons, just like your Ola or Uber or G Maps, each is highlighting which and every module has a problem. If you click on that particular marker, you'll be able to see the corresponding thermal image also. Right. Now, this is great. Looks like quite technologically advanced. But what is that thermal image? What is that behind this technology which is helping us to understand the problem? For that, let me directly show you a practical video. When I was saying that we do thermography, this is what a thermal image looks like. Okay, a thermal image, basically what you see here is a thermal capture of taken from drones of solar panels. Don't worry, you will see a variety of colors. Basically, yellow color is indicating a particular kind of temperature, and other purple colors and all is including a land temperature. Okay, each and every color pixel is giving information about the temperature value of that particular pixel. Again, questions are welcomed, right? Going ahead, it's important to understand what are these modules okay or they have some problems. Let's see one by one. I will play the video now. I hope the video is playing clearly. Now the drone, if you see, it's moving. This is how the drones can actually scale. Now within this just 2 seconds you saw, it literally inspected 50 modules just within 2 seconds. Just now you saw that. And here we are just looking at it, right? Imagine we are talking about 500 acres and even, 1,500 acres and 11 lakh modules, right? That's where the AI engine helps. Now the drone is moving. Yeah, now it's taking a turn at the borders. Let's see where it goes now. Okay, there is some tree here. Wait, did you notice something? Did you notice this? There's something wrong. We don't know what it is, but let's go in detail. What is that? If you see, there is a tree here, right? The tree is casting shadow of solar panel, and that solar cells are having shadow, are having higher temperature as discussed than the normal operating cells. That's why these are called hot spots. And the signature is indicating a multi-cell hotspot over here due to the shading. This video is taken from the internet, by the way, right? And this particular hotspot temperature helps us to identify what is the problem in the solar PV module and potentially what could be the power loss due to this. Now let's go ahead. Okay, did we notice something else now interesting? Something over here, right? I mean, if this was an in-person session, I would love you guys to point it out, but yeah, we see something problematic here, right? If you see, we discussed that there are 72 cells in solar panel. And if you see that 1/3 of this module is having some particular band or some particular signature. Remember, there were 3 bypass diodes in solar module, and one diode was taking care of the 24 cells. Now the diode gets active basically because there could be potentially some problem in the solar cell, and that particular diode is active, so 24 cells are not producing, inactive. And basically this is what is indicating that the diode here is active and the 24 cells are not generating to the system. That's why the cells which are not generating to system are having higher temperature. Higher temperature is the yellow brightness is higher as compared to normal operating cells. This is called a bypass diode active problem in a solar PV module, right? How to fix this? What are the ways? That goes the solar ways, right? Would like to connect personally if you would like to know that. Yeah. Let's go slightly more, some interesting finding out, and let's see if there are more problems. Oh wait, there's something here. Right? Interestingly, there is a grass from the ground which is growing, creating a shadow on solar panel, and you see a hotspot there. Wow. Oh, another bypass reactive model over there, right? We just now saw them. This is how the potential of drones is in inspecting solar PV plants. Quite interesting, quite exciting to see. And oh, did we see something very interesting now? why are these solar PV modules are having so high temperature as compared to normal operating modules? We just discussed that cells which are not active will have higher temperature than normal operating cells. And that's where we realize that the electrical connection for this particular string of modules is disconnected. Could be that the connector is burnt due to arcing, or there is a rat which has come and bitten the wire and there's a disconnection, open circuit. That's why these modules are not generating. And that's why we see that the panel temperature is higher, right? This is how now indirectly all the solar panels are not generating the system. Remember, when we see this through actual physical RGB visual camera, we cannot see such details. This is a thermography technique, thermal temperature differences. That's why we are able to make out such problems. Pretty interesting, right? That's the power of the drones along with thermal imaging to diagnose problems in solar PV modules and identify the problems, not only identify, give an understanding of what could be the problem beneath, and also how we can rectify that comes from the solar knowledge. This is how we have been helping solar industry globally with almost 50 gigawatts plus of assets, globally inspected using drone-based solution, right? The very interesting part of this solution is how we can use people in Australia, people in South Africa, USA, UK, Europe, everyone can use this. How? Basically, they log into this portal, there is a training module. They undergo training on how to fly the drones for this particular solar inspection. They fly drones themselves in their local solar plants. They collect the data, they upload onto servers, and here is where you get the solution ready. So now this platform is not only used in India, it's used globally, right? And any pilot who has a drone and a thermal camera can actually fly and collect the data and make business. Now, this particular has a potential not only solving solar PV plants, but also generating business for drone industry. That's where this is a transformation of technology, wherein we are helping multifolds in making sure that the solar assets are more reliable and efficient. Right? Now that we saw the video, quite interesting. Now, there's one more challenge in operational solar assets, right? It's about the shading, right? If you see here, there's a jungle area and there is a shadow which is casted. We just now saw an example of how a temperature signature looks like when there is a shadow. Here you see there's a tree casting a shadow over a set of solar panels. Is this an issue? Yes, definitely it's an issue because solar modules are connected in series. So if there are 5 modules here which are having shadow, it will also impact the other modules in series, right? Now, how to practically understand what are the losses due to this tree shadows? How to practically understand? Conventionally, what people are doing is people are using simulation softwares like PVSYST. They are modeling the solar plants onto PVSYST, right? And then they are actually trying to see the generation. Interesting part is they actually even model manually trees, tree heights, and other details manually onto the simulation platform and try to see the shadow losses. But is it practical to actually measure very accurately at centimeter level the heights of the trees, heights of the objects, heights of the buildings, water tanks, so many other details in and around, and model them manually on a simulation platform? Very difficult. That's where the technology of drones comes into picture, right? On the left side, you see how simulations are done without using drones manually. And manually, we can actually insert trees, right, of defined height. And the right side you see is how the drone technology is transforming the energy generation simulation as well, right? What we do is we collect the data of the surroundings using drones, right? And we form a 3D model out of the entire environment, a 3D model from the images collected. Now, the interesting part is the 3D model, we process it further to use it on the simulation platforms, right? When we use it on the simulation platforms, we actually perform simulations along with the real world scenarios. Remember, this real world data is accurate to centimeter levels. Now, basically, we are able to perform much accurate simulations of plant performance. And here is where the investment decisions are taken, whether to invest in such a construction of plant in a forest area or not. Right? So another interesting problem to solve is, can we actually install solar PV plants with objects in and around large tall objects in and around? And if yes, what could be the performance? How could we actually simulate it? Use drones, make 3D models, process the 3D models such a way that you can bring that into simulation environments, simulate, and that's where you get the performance results. This is another one of the interesting solution we have for drones in solar to avoid and compute shading losses, right? So I guess we are almost near to the end of the session, right? And as I had promised, I will obviously show you a demo of how to actually automate and fly a drone and how to program it. And how difficult is it to program a drone? Actually, it's very simple. But what we'll do is because it's going to take not more than 5 to 10 minutes, we can actually go forward for if there are any questions, right? For this session. Because after this session, we basically after this presentation, we are jumping onto a platform of simulation for drone flight planning. We will do that and then we will conclude the session. Yeah, happy to take questions if any.
Yeah, thanks, Kaustubh. I could see good number of questions are lined up. Let me take one by one where we left off. Quite a lot of them. There's a question from Muhammad Irshan. Muhammad is asking, is there any way to store this huge extra solar power if the solar park is generating more power than required? So his question is more on the storage side.
Well, I mean, you might feel that I'm just saying interesting questions, but actually they're all interesting questions. I mean, I'm happy to hear this out. This also indicates the curiosity of the members involved in the session. Yes. So the question is there any way to store solar power? And when there's a potential for solar to generate more, how can we leverage that? Right? Basically, yes is the answer. The future, if you have heard about this solar industry, we have solar battery storage systems coming in, right? In rooftops or in residential solar, you might have even seen solar like inverter battery systems already. But when it comes to such a large assets, yes, internationally battery systems and even in India, battery-based systems are already under construction. It is new to the market. I cannot say it is like quite old technology. It's upcoming technology. We are yet, I mean, the industry is yet to experience it. How does it perform? The advantage it brings on the table is, as you rightly said, if the performance is more, but in the, you know, the duck curve of the electrical, if you are aware, right? In the afternoon time, right, the energy consumption might be lower, but in the evening time, the energy consumption might be high. If that is the case, how we can actually generate, store the solar power generated onto batteries and actually inject them in the evening time or night time? That's possible. It's practically happening. It's already implemented and the industry is transforming towards it. Yes. So answer is it's possible to store solar power into batteries, even in such a large scale. Yes.
Great. Thanks, Kaustubh. Irshan, hope it clarifies, Irshan. There are some more questions. We'll take it. Again, Sanjeev is asking another question. Sir, you told that high temperature PV cells less performance, but we know that high intensity of solar light produce more electricity. So as this
Correct.
concept high temperature give high electricity, can you correct the relation?
Can you repeat the last sentence, Jacob? Last sentence?
He's telling the concept high temperature give high electricity. That's what we all
Correct.
understand, right? Read it out for
Correct.
you once again. You told that high temperature PV cell less performance, but we know
Correct.
whatever you put a simulation where you showed that, right? There's a high temperature. You said it is not working, right? That's what we could
Correct.
sense. But he's telling on the other hand, we have this idea of high temperature means it gives high electricity. So how do we basically correlate this?
Correct. Basically, the point is high temperature, high electricity, no. High temperature, you might get much more heated water in your water heaters, solar water heaters. Solar photovoltaic principle is different. Remember, do not mix and match the terms of irradiation and heat. Irradiation is different. Heat is temperature is different. Irradiation is the number of photons falling onto solar cells. It's not related to heat, right? And temperature is basically the property of the object itself. Now, if you see this graph, as I said, irradiation increases, the power output increases. Yes, that's what you see the IV curve. But if you see that the temperature increases, basically solar cells have a property of negative temperature coefficient. They are negative temperature coefficient materials, due to which higher temperature they have less ability of electrons getting absorbed and basically absorbing the energy and jumping into the conduction band. That's why higher temperature, lesser performance, but higher radiation, more performance. So it's directly proportional to radiation, inversely proportional to temperature. Yeah, these are the curves you see.
Great. Yeah. Hope that's clear, Sanjeev. There's a question from Balaji Madhu. Balaji is asking, can't we install basically CC cameras to monitor theft issues, and at the same time by using some coding to identify the problem?
Absolutely, yes, we can. And in fact, it is done. It's already followed. For this is the security problem in solar PV plants. When you have 1,500 acres and drones cannot fly always, like drones have batteries and the batteries will die down in half an hour and they have to come down and fly again. And you never know if the drones are flying in the air continuously, birds come and attack the drone damages. And a drone's cost worth 10 lakhs rupees and you lose the 10 lakh rupees in one shot. CCTV cameras are being installed practically in majority of solar plants, and those are playing key roles in security measures as well. They are installed at the compound wall, at the perimeter, and also they monitor, they have real-time video feed in. There are also AI engines running on the CCTV footages to identify intruders and generate correct alarms indicating the positions. And this is the key of security of the solar assets. Only problem is during construction, there is not always the compound wall, is properly built because everything is under construction. But for completely operational plant, yes, CCTVs play a key role in security. Yeah. And there's a
Great.
huge potential there as well. Huge potential of a problem there because CCTVs are expensive. We cannot cover the 100% perimeter of 1,500 acres. So it's an interesting problem statement for engineering students on how we can use a combination of certain more sensors. I'm just giving you a hint. Combination of other sensors with CCTV, which can actually cover the blind spots across the perimeter because it's not practically economical to install CCTVs in each and every point to avoid blind spots in solar plants. That's an interesting problem to work upon as an engineering project. Yeah.
Thanks. So Balaji, hope that's clear. One more question before, I think I could see a lot of them, but I would, don't want to choke your time, Kaustubh. Let us take one more question and before we move on. There's a question from Maz, our partner, like my partner, Mr. MD of Emertxe. So he's asking, Jai, can you ask Kaustubh what they mean by, so many gigawatt plant capacity? In what duration that much power is generated?
Yes. Hi, Maz. Nice to meet you. Basically, watts is the instantaneous power. So when we say megawatts, right? If, say, example, a plant is 100 megawatts, when the solar radiation falls on it, right? Instantly it generates 100 watt and basically 100 watt hour. So in 1 hour, we get 100 watts of energy generated. So basically 100 watt hour. Okay, so the unit megawatts or gigawatts is basically indicating the energy generated in 1 hour by that system.
Okay, all right. So I think there are still a lot of questions, Kaustubh. I would request you to move on. We'll see, as I said, we need to keep the time also in mind. We're almost like 8:30. Please proceed. We'll come back and take. Guys, I could see a lot of questions. Your question is not answered. Please hold, don't feel disappointed. All the questions are here. I could see questions from Satish, Drupajyoti, Vinay, right? A lot of questions are lined up. Let us, proceed and then we'll see how much we can take towards the end. Please proceed, Kaustubh.
Sure. And don't get disappointed, guys. After this session, I will share the mail ID and I'm happy to get more queries as well. Not a problem.
Yeah.
All right. So basically now the time is to go towards the demo, right? So where were we? Slide. Yeah. We were here. Yeah. So first question, when we are talking about drones, we saw a video of drone flying. How do they fly? Do we need to manually control it and fly and go to zigzag path as we saw manually with the sticks of joystick? Is there any automated way? Yes, that's what the demo we're going to see about. If it's an automated way, how to program drones? Is it about Python scripting, C programming, and so many codes? What all factors it involves? And how can it automatically fly? What are the patterns we can generate? And how to control it? There's so many questions which come on. The drone industry is getting so matured with the technology now that without a single letter of program, we can make drones fly completely automatically. by just one single button, start, right? And it automatically flies, traces around the path which you decide, which I will show you how to do that, comes back, lands in the position which it had taken off whenever there's a battery problem. Also, even if there is a high wind, it gives warning, it comes back. Now, this is where the technology is already advanced in, and that's why they're expensive systems as well, right? But how is all this possible? And can we get a glimpse of how a drone flies in a solar PV plant? We'll see the simulation. So I'm using the Drone Link software, right? And first of all, let's go how to program a drone, right? I'm just taking a demo. Basically, this is satellite view, right, of a solar plant, right? And if you see, we have drawn a polygon here, a area, something which you might, if you guys know Google Earth, something you can do on that also. Now, if you see that this blue lines are indicating some path, right? And this is actually the drone path. Now, how to program this and what is it all about? Let's go step by step. Here, first I create a component, and this is about Drone Link, right? There are many such softwares available to do. I decide which drone I'm using, what is the overlap, the details and others, what altitude it should fly, is it capturing photo, video, what speed it should fly. All the details are just given here on the way I have to make the drone fly, right? Once it is done, right, I connect this particular simulation, basically this planning software to the drone, and then I feed in or flash this program in your language, right? Now remember, it's so interesting that if you don't want to go into the numbers, just play around with this. What do you want to do? You want to go this way or you want to change the direction? Just move around these points and you will be able to control the path of the drone. Now you will say, Kaustubh, this is just zigzag path. But what if I want to do any random path? No worries. There are many components like this. You can just trace your mouse and you can make any 3D parts in a complete 3D space of of the air. There is sky's the limit, right? Obviously, drones have altitude limit, but yes, that's the limit. You can generate any 3D path in any direction, XYZ plane, and program this just using such platforms. There are multiple such platforms available. Interestingly, now what I will do is, this is solar PV plant. How do we perform inspection? I will show you a quick simulation demo on this. Right. Now, what you see here on screen is basically the solar plant. We have programmed a polygon and we have programmed a defined path. This red color dot is indicating the drone, and this is the starting takeoff point, the first point wherein the drone will start the inspection or data capture. The right side, what you see is basically what the drone's camera looks at. So the drone view you'll be able to see over here. Remember, this is simulation only, right? But this is for you to give a flavor of how drone, after you program a drone, automatically, how does it fly? As I said, one button. This is the button. I click it, right? Now, if you see this, the drone is basically now taking off. We have set the parameters altitude to 30 meters. It's indicating the height here. Now it has gone to 30 meters. Now it is going towards the first point. This is how the drone actually is automatically moving just by the one button, right? Now it's ready for the inspection. The camera is pointing downwards. This is the field of view of the image. And here is, you see, this is a satellite view, so don't worry about the clarity. But this is how the drone is actually capturing images and scanning the solar panels. Interestingly, if you see that this is the field of view, and there is slight kind of overlap between the image or the field of view in this row versus this row, right? This is to ensure that 100% of solar panels are covered, right? I'll just make slightly faster by doing 4x. And this is how the drone actually is moving around the solar plant, inspecting the entire solar asset, right? You can see the video there of what the drone captures. Quite interesting, right? And everything is automated. You saw, I just clicked one button. And after it ends the mission, it automatically comes to the original position, lands on its own in the landing pad, right? This is how interesting the drone flight planning is. How much time it took to plan this mission? 5 minutes. You saw I didn't write even hash include stdio.h, right? This is how advanced the drone technology is now. This allows anyone and everyone to actually plan the flights and fly the drones and derive the value out of it. Now, here is where, without focusing on coding, but using such technologies, we're actually making it fly, right? However, remember, this looks all so good on the platform, there are so many advanced engineers who have put their days and night together to actually convert this, what inputs as a layman user is giving here, to convert into the coding. So what runs behind this is binary codes finally. So it's a series of things which runs through Python, C, binary, and then flash to the controller onto the drone. So it's not that, okay, drones are so simple. Drones are actually made simple thanks to the engineers globally working in drone industry to design such advanced robotics, right? This is how we actually inspect solar PV assets using drones. And this is what I wanted to show you, a final demo. Now, another click to pause the simulation. With this, I conclude this session, and thanks for your time. And that's my email ID. Happy to connect if you have any questions directly as well. Yep, now again, open to questions if there are any. But yes, would like to also know how was the session from your side as a feedback. Yeah. Yeah, Jai Kumar, if there are any questions, let me know.
Oh, sorry, I was on mute. So there are a good number of questions. So let me go over one by one. So Vinay asked a question where, can we reach a point where we can start placing panels out in space to extend to full potential of harnessing direct radiation? So can you move it like a space station?
Beautiful, beautiful thought. So regarding can we mount panels on space? I mean, that's where the satellites are actually being powered, right? That's the base of energy for satellites. Answer is yes. Satellites are running through solar panels. That's the only source of energy they carry. But there's another interesting thought. There are many startups, high cutting edge startups who are working on solar flying planes using solar only. Obviously, NASA, if you have heard, NASA had built a plane 3 years back, only powered by solar, which actually took one complete revolution of Earth and came back to the same position. I guess the time taken was 60 days or so. One complete revolution of the Earth non-stop using solar power. So only question is, if you want to harness solar energy in space and bring it back to the ground, that is something challenging. But yes, harnessing solar energy for remote objects to operate and function as satellites and hopefully in the future planes, yes, it's already happening.
Great. Hope that clarifies your question. Yeah, Vinay already says thank you. There's a question from Muhammad Irshan. So he's asking, is this application open source? The simulation which I showed.
There are few open source applications as well. The one which I saw has subscription. Basically, we use that for planning our commercial drones. But again, I guess there will be some trial version available. Feel free to play around with it. Yeah.
Okay. All right. So there's a question from Dhruba Jyoti. Dhruba Jyoti is asking, does infrared imaging suffer from noise as we face noise problem in normal image processing? How different the IR image
Absolutely,
filtering
yes.
technique than the normal image filtering?
I like that question again. So this is an example of IR image. Can we have noise? Yes, lot of noise. No other, I mean, every other practical problem is not as easy as the sample data sets you get in your theory projects. It's not as easy as that. Why? Because noises do exist in any practical application. In this case, sun's reflection over solar modules, the glass, is creating a problem in the thermal sensors, giving erroneous data. That's why it's important that we capture multiple images of one solar panel to ensure that we are not missing out the data. Apart from that, the noises also do exist. There's a reflectivity concept in thermal imaging, which can create problems, which can give erroneous temperature values. And apart from that, the temperature in and around surroundings itself can be a noise, which can actually make the data so dynamic and not constant every time, which makes the deep learning model and computer vision model development much more challenging. But yes, noise does exist in every practical application, even in IR
Great.
images.
Yeah, great question, Dhruba Jyoti. So there's a question from Satish. Satish is asking, sir, is it possible to do the maintenance of solar cells through drones instead of using manpower? It's going probably thinking one level. Okay. Doing the maintenance part.
Okay. What we saw the piece was detecting the problems, right?
Mm.
Now, see, if you see how to fix the problems, it's what it involves. It involves cable joint, fuse change. These are not possible through drones. These are manually done. But if you ask me if robots could do in the future, could be. But again, finally, it's the hands of engineers which will do it. But you never know in the future, robots could do it. Drones will not do it because drones have limitations. They are flying objects. The drones in sync with robots could do it, but it's highly futuristic. And considering the economics, it has a long path to go. But yes, the problems involved are physical in nature, which involve handling components, fixing components. That's why it's not so, yeah, drones are not the solutions. Robots could be in the future.
Right, right. That's more of a combination of drones and robots. Right.
Right.
So the question from Harshraj. Harshraj is asking, sir, recently came across an article that says a new type of solar cell has been invented which generates electricity at night also. Can you please give some information regarding that?
Okay. I have heard about it, but I don't have much information on that. If I'm right, if it's generating in nighttime, it's basically using moonlight. But unfortunately, I'm not aware much of the details. But I know that there is certain voltage being generated even in nighttime due to that slight moonlight radiation. But I'm unfortunately not aware of how the tech works there and what is the technology behind it. Internet
Oh,
can help
no. Yeah. So there's a question from Ravi Kumar Gupta. Ravi is asking, which simulation used to extract data from 3D image that comes from drones?
which simulation is used to extract the data. I didn't basically with simulation tool. Okay. If you're talking about this particular tool, basically PVSYST is a common simulation tool used in solar industry widely to understand the performance generation. We build the 3D models and we process the 3D models in Dronebase to import that models into PVSYST and actually perform the simulations. Now, coming to the question of how 3D models are generated using drone data, there are various tools available. Also, we have developed our own as well to actually form the 3D models from the drone data. Yeah, Google is the answer.
Okay.
Google can
Okay.
help you there.
Okay. So there's a question from Gaurav. Gaurav, goes all to the commercial part of it. He's saying, can you please explain what are the expenses in a 1 megawatt solar farm? Right, maintenance, employee salary, taxes, unit generated profit, the economics part of it.
Great. I mean, we should meet separately and talk personally because it's dynamic. But as I said, overall scenario, 1 megawatt is 6 crore. That's just about the construction investments, right? And yeah, and there are many other details, and there's a checklist of the costs involved in operation maintenance, and even a lot of activities being happening at the site on a regular basis. It's a detailed one, but on an overall scale, it's 6 crores per megawatt. It reduces and increases based on the market.
Great. There's a question from Venkatesh. Venkatesh is asking how drone is capturing data from solar panels and sent to the server. Which protocol is used? And we use SIM card in drone.
What? So basically, currently the drones which are using are storing the data locally on memory cards, and then we have to transfer it onto servers manually. But there are ways, basically there are dock stations wherein the drone can land on its own on dock stations, and then basically the data transfer can be done. And over cloud, basically what happens is solar panels or solar assets are installed in isolated areas, not in like city areas. So the internet network is not that strong. Everything goes onto mobile networks or dedicated broadband lines, right? So yes, how it works is if there is a automatic way which anyway exists, right? Which wherein there are docks. Docks is basically a base station for drones. The drones come and settle in docks on its own, and then basically the data is extracted from drones using a lot of techniques, and that data is pushed through internet. It can be if it's wireless, it's through 4G, or if it's through broadband, it's pushed to cloud servers. In Dronebase case, we have it on different platforms, and that server data then the further processes carry on. But yes, it's kind of a generic answer because it can be any way you can use. There's no specific standard protocol we need to use to transfer the data. It can be any available way because not everywhere you have internet in solar plants.
Okay, great. There's a question from Ravi again. Environmental temperature and solar temperature read drones. Which technology and method to identify data of solar panel?
Can you repeat the question, Jaykumar? The first point?
here, yeah, environmental temperature and solar temperature.
What is that word? In?
I'm not clear. Okay, I'm not clear.
Inwardly. Okay. No, that
I
word
think we'll,
inwardly temperature. Okay.
yeah, I'm not clear. Ravi, can you just type the question once again? Because we're not able to understand what exactly we're talking about. Okay, let us go back. Then again, there's a question from, please go up, there are many questions. So can you tell in cloudy weather forecast how solar panel work?
Yep. So basically, cloud conditions is what? When you have cloud patches, you have radiations reduced. You have the answer here. Cloudy conditions, we have lesser generation because it's all the game of radiation. Higher the radiation, more generation. Lesser the radiation, less generation. The interesting question would be if you have 1,500 acres and there's a cloud patches coming in, there's so much of mismatch of shadows, right? That's where there are challenges. That's where the challenge is the mismatch of shadows. And yes, there is a partial losses which are generated due to the cloud patches when it comes to such a huge, large area. But yes, it's the game of the radiation and generation, lesser the radiation, lesser the generation. So yes, cloud patches or cloudy weather conditions are enemies to solar generation.
Okay, great. So question from Vinay again, how the cells can generate electron flow? On what principle do they function?
We discussed this, the solar photovoltaic process, the silicon cells, basically, again, if you're going detailed into chemistry, I have to also read it. But yes, the photon energy is transferred into the electron, which is based on the valence band that absorbs the energy, goes to conduction, electrical path exists, then there's an electron flow due to the potential difference. Yeah.
Okay, great. I think we fairly covered all the questions. Is there any more questions? Guys, any more questions? Pretty much, there are some questions which I did not read because either it is answered by some other question asked by other student or, post office already answered them. Yeah. Okay, there's one more question here from Satish again. Sir, in solar panel, performance depend on height of the panel installed from surface, base, other than angle direction.
Not much. Height does not impact much. Yeah. Height does not impact much because we are talking about sun, which is 3,500 light years away from us. Yeah. So even if you take solar panels on commercial airplanes and try to see, you will not see a big difference. Actually, the height does not matter much because we are the whatever altitude you take relatively is very low when compared to the distance of sun from the earth. Yeah. So not much of difference.
Okay, great. Again, question from Mohammed is asking, Mohammed Irshan. So can we use air charge technology in drone?
What technology, sorry?
Air charge, to charge them, charging the drone from air.
Charging the drone from air charge. Okay. Air charge, no. If you are talking about something like wind turbines on drones and charging it, unfortunately, practically not possible. But charging on charging stations, docking stations do exist. Mobile docking stations do exist. Wherein docking station is basically, it can be a mobile van or it can be a static station. The drones come in, land, then there are chargers inside, super fast charger, turbo chargers. They get the batteries charged or replace the batteries, and the drone is ready to fly again. There are docking stations available, but air charge not possible. It's basically a game of
great.
It boils down there. Yeah.
Okay. So one last question from Sanjeev again. He's telling, sir, in PV cell, which type of diode is used in 4007 or another one?
Okay, which diode? Okay, the product code, the part code. It's not IM4007 because they are basic ones. Basically, for PV, there's a particular rating. I don't know the product code though, but yes, the ratings are usually designed in such a way to handle almost 9 amperes of forward current, right? And the potential of almost 0.5 volts into 24. That's the voltage rating and current rating. Yeah, but it's not lab ones which you see. They are quite these diodes are quite big ones. Yeah.
Yeah. So maybe again we talk about the controllers, right? We learn certain 8051, but that's not what it is getting used in the real time, right? One is for the learning purpose, another is for the They you know, and as you are going for the commercial, things get very much vertical centric, use case centric, and things like that. Right? Okay.
Very true.
All right.
Very true.
So we'll stop the questions now. I know I've seen questions coming out the quiz. Let me check that. But before that, can I get some feedback about how did you find the today's session? That we can read out to Kaustuv. How did you find this session? I saw already a question and statement from Prashant. He's telling, excellent session. And then he's giving me a thumbs up like that. Sir. And then Aniket is asking, sir, add this webinar in Moodle also. We'll do that, Aniket. We already anyways put these videos in YouTube and it's open for everybody to see that. And we'll try to put it in the Moodle also. Maybe we'll create one section for masterclass webinars and we'll do that. Then there are a lot of feedbacks coming in, Kaustuv, for you. Gaurav Kulal says absolutely great. Vinay is telling informative. Then Ankur is telling it was great, sir. Then Aniket is telling excellent session. Enjoyed a lot, sir. Sripati. I think that's very important, right? And the beauty of today's session, it gave you guys a view, but it did not confuse you or it did not put you in a difficult state. You presented it so nicely. Vetrivel says great session, and Ashutosh is giving 3 thumbs ups. Nice, sir.
Thank you, guys.
Then Irshad says, Irshad, you're asking for social media ID. The same thing I would suggest Kaustuv Karnataki, right? I think he's quite active on LinkedIn. You can look up to him. I'm connected to him as well, right? And Harshraj is telling, amazing, sir, want to work in this domain. That's great to see that. And Sanjeev is telling, great session, lot of confusion got cleared, which is pending from college level. Okay, glad to see that.
Nice.
Absolutely interesting. And knowledge upgrading, says Shweta. And then very informative sessions, says Ayush. Excellence are very interesting and information, says Satish. Fully informative and interactive, says Prajwal. I enjoyed a lot, sir, says Kishore. Session was very interesting, sir. We don't know how 2 hours went, and the way sir explained was very easy to understand. I think that's what I was, I could see that. Very, very amazing way of explaining. Usha Meena is telling clear and crisp explanation. And then there's a Hindi comment from Harish saying, Pata nahi chala, time kaise gaya. It was a great session. Great to see that. Sashmita telling excellent. And then again,
Thanks,
similar comments, very informative and interesting how 2 hours went. We don't know. Okay, now coming to the quiz code. Just hang on, Kaustuv. Let me open screen is visible. Yeah, you can see there. The quiz is already live in our Instagram. Maybe a couple of stories are in the beginning. Just ignore that. The quiz is already live. So please log into our Instagram. It's Imagery Instagram. Imagery IT is our handle, and we'll keep this quiz open. And please ensure that you guys put the correct webinar code, because we don't want anybody who has not attended this webinar to attempt this particular quiz. And let me show you the quiz code once again. And I also uploaded in there's a section called handouts. If you guys can see in the right hand side of your GoToWebinar panel, there's a webinar code.jpg. I have just uploaded the image as well, in case if you're not able to see it and type in your screen, right? You can download that image and then you can put that particular code, right? Are you able to see the code in the handout section? Also are able to see the code in the screen? Hope that's clear. All right, yeah. Ankur, Kishore. All right, guys, we'll keep it open for at least maybe till tomorrow morning, or even a little bit more. Tomorrow is Sunday. We'll keep it open, and as always, the quiz will get evaluated, and our team will reach out to you with the winners. Winners will get some goodies, and all the participants will get certificates. That's to get ourselves motivated. Okay, and also the winners whom are got right, we'll also publish in our social media, just to give you guys certain motivation. You can show it to your friends and say, hey, I won a quiz and stuff like that. Okay. So with that note, on behalf of Emertxe students and also our team and also our management, I want to thank Kaustuv for spending his valuable time. I know it's on a Saturday evening, we all have different commitments and plan. Thank you very much for sharing your valuable time, Kaustuv. It was eye-opening for me, especially I come from totally different background, and this one was really eye-opening to understand how the large-scale challenge that we are up against, and how technology can solve the problem more efficiently with much lesser time and much better efficiency, and how by doing all these things we can have a better future. Okay, so thank you very much for your time, and I can see still a lot of positive feedback pouring in from students. Okay, I'm just running out of time. A lot of thank you messages, a lot of messages. And by the way, guys, we will anyways bundle this slide deck. We'll get the deck from Kaustubh. We'll also bundle this video and email to all of you, share it via our Google group, and also put some message in our WhatsApp, student WhatsApp, and also so you can download these things, and and feel free to share. The idea is of these sessions is to open up minds. I hope that's the reason you can see a lot of exciting messages coming in, that I want to have such career in my future, and this is how the future looks and stuff like that. I sincerely hope the two M's which you spoke about, the mentoring and motivation, open up your minds, and we all do better as we move forward. Okay. So thank you very much for all of you who attended the webinar today. So thank you very much, Kaustubh. And we'll come up with the next edition of our Emerging Technology Masterclass webinar series in the month of June, first Saturday of June. Okay. Till then, take care. Thank you very much, Kaustubh. See you in the next webinar.
Thanks
Bye.
again. Thanks, Jayakumar, for this. It was my pleasure. But yeah, thanks. Nice meeting everyone. Let's stay in touch. Bye.